a change in pressure at any point in an enclosed fluid at rest is transmitted undiminished to all points in the fluid. Okay, there's a basic definition of it. So what do you mean by that, sir? Okay, fine, you gave definition. You gave definition, everything. The change in pressure, so will be in an enclosed fluid. I think this is what very important. Again, if you say that, if you don't write enclosed, no, this will become quite meaningless. So let me take a ball. I'm going to hold it. I think you can take polythene. These are the fingers. I'm trying to show the fingers. Okay, other finger will be other side. I'm don't know. So I'll fill up. So what is this? Let me take some polythene bag. I'll fill up water in that. Then with my thumb, I'll start pressing it. It's a very good example you can try in your room. Then what I see that it will be transferred to all points of the liquid. And the liquid open will transfer to our fingers also. But how the liquid like that force normally, no? So it will be like this. I need some other color. I'll put dotted one because the forces. So there are, we have to, so what is this? The liquid exit force normally. Now where it is in contact, it will be like this. So what is the role of liquid? It will just transmit that particular external pressure to our palm. So what is the role of liquid? It's like just like a transmitter. It transmits the pressure. So I with my thumb, I pressed it here. No? With my thumb, I pressed it here. And what this liquid do? It will transmit everywhere here like this. So I'm not saying it will transmit force. It will transmit the pressure. What pressure? With thumb only, with one thumb. I think the best definition is what I'm giving to myself. I can't take better than this one. Okay, this is our human hand. I could have given the definitions which are there in book. Okay, that will not reflect. So with my own all fist, what will happen? With my whole palm, I'm exerting force on the liquid or only that one. So only using thumb, only thumb will happen, I'll press it. So this is like a thin rubber shell. This is a liquid. So because on the liquid, I can't hold like this. No? With only thumb, I'll press it. I'll exert a force only using thumb. and if a pressure is exerted on the, and the liquid open will transfer that pressure to the total palm like this. What pressure we exert, that pressure will be transferred here. Sir, is it will transfer force? No, I'm not saying force. So what is the force here? What is the pressure here? The force per area, the thumb, it will press. Only this much of area to take it, that F by F1 by A1. What about here? Here F2 by A2. So don't say it will transfer force. I think you're killing the total Pascal law. So if I slightly change the pressure here also it will change. So what all changes I make, that will be transmitted. We will transmit the liquid. So what is the liquid here? The liquid will act like a transmitter. Acts like an agent that transmits the change in pressure. So that's what I'm bothered now about application, engineering application. So here I'm not applying, so pressure, external pressure applied at one point. So what about here? What we feel? We feel everywhere here, no? The blue colors. The external pressure applied at one point is felt at several points. So who will do that? The liquid. So here, so we'll put explanation further. At several points on palm. The pressure is felt. I think there's a basic idea of the Pascal's law. So there's a definition. I felt like there's a one best example which you can take it. What is the use of this? What is the basically use of this? Let me take directly one application problem. I want to lift a vehicle or a truck. I want to lift a vehicle or a truck. Can I do that as very easily with the help of a setup? No, I'll ask you, can you lift a truck? I'll say yes. Sir, are you Superman? You can ask me. I say yes, I'm Superman. I can lift a truck. See, what you want? The truck should be lifted, raised up, no? How I do? Why Superman will lift? Because he's from Krypton planet and is having sufficient energy. I'm from Mother Earth planet, so I have some energy. But I do have brain, and I know Pascal's law. So with the help of Pascal's law, I'll lift him. So I'm also like Superman only. Okay, fine. So there's a overall truck it is. So even if you want, you can place a good. So it's a heavy truck. It has to be lifted up. Yes, I can lift by using this one. So here, there's everything is a fluid. Let me show that blue color fluid so that it will help you to understand the concept. No, I have to make a lever. Let me construct that lever part. Since we know a little bit rotation mechanics, I'm taking help of that one. Can you hear me?
Yes, sir.
Yes, sir.
Yeah. Some power gone with mobile data. Will continue the class. Now the lever can be asked in advanced exam, so you have to be careful. Just I'm exposing you to the like that will be fixed here. So by pressing this, now you see the setup. If you want, you can construct such things in home. I think remaining things later on I'll collect. It will take more time coloring. I think it's a physics class, not drawing class. No. So as I press this lever, so this particular thing, so with the help of that weapon, this particular thing will be moved. So this particular thing will be moved. So as I press this hard, as I press it down, so the movement will be like this. As I press it down, so this particular thing, what happens, this will move down, this will shift, and this will come like this. Will I agree? This will be fixed to not this particular thing, this will be fixed to this particular connection here. So as I press this, what will happen, this will make it to move down. As this moves down, so this will move down, then this will start moving up. So I think that I'm able to lift the truck, finish all. How I lift, I'm not bothered, but I'm lifting the truck or not. So Superman comes, directly lift the truck. It doesn't need all this Pascal's law. So here, the pressure what I have generated here will be transmitted by the liquid. Are you looking at the red color arrow? It will transmit like this. What all pressure I generate here will be transmitted. The red color arrow is the transmission of the pressure. So area of cross section of this, let it be A1, this will be A2. The weight of the truck, let it be W2. The other things, the piston will not have anything. So I applied a force here, say F. Altogether, I applied a force, some other thing here. At this particular lever, everything is called like a lever setup. This will be F1, you call it. So then what is the pressure at point 1? F1, A1. What is the pressure at point 2? W2 by A2. According to Pascal's law, pressure at 1 should be equal to pressure at 2. Of course, there'll be a small height difference there. Okay, let me make it at same height. No diagram, I have to change. Same height first will do. So then other thing I will. First, let me explain the Pascal's law, then I'll go for application. Yeah. Okay, now. Try to see this. This will be much easier. The pressure will get transmitted like this. So this is 0.2. So pressure at 1 equal to pressure at 2. What is the pressure at 1? F1 by A1. What is the pressure at 2? W2 by A2. Okay, there's a trick what I'm using here now. So how much of F1? F1 should be very large. No, it is A1 by A2. No. So though I know that weight of the truck, is it that 10 kg, 100 kg, 10,000, 2 ton, 3 ton, 4 ton? No. So what is the force required? It all depends on A1 by A2. how much of smaller you make A1 by A2, that much of smaller force will be available here, because W2 will be very much greater than F1, but A1 by A2 will be very small, so that some around 100 Newton, 200 Newton, with that also you can balance this truck. I think something very good, no? This is, so this was the method. How do I lift heavier objects by using Pascal's law? If you go for the harbor, sea harbor, no, the Pascal's law is what everything. Such a heavy containers, how they'll be loaded onto the ship using Pascal's law. So when you press hard here, this particular setup will be moved here, and this will be fixed here. Many are asking, no?
Sir,
So your voice is cracking,
Voice
sir.
is cracking, sir.
Voice is cracking. I will set right it. Okay, this piston 1. Okay, there's a piston 2. Pistons are movable. Now, okay, voice. Can you hear me clearly?
Breaking, sir.
Sir, still cracking, sir.
Breaking. I'll set that thing. Now. Can you hear me?
Yes, sir.
yes, sir.
Okay, no, we'll continue here. Okay, this is about the basic Pascal's law. Okay, now one more last of this, then I'll wind up this topic. This is the difference. Is that so? There's a heavy block. Can I balance that heavy block using this? So inside here, everywhere liquid will be present. So the difference in the level of pistons will be A1 and so like the height H. So here the liquid is present. So even pistons will have a mass. In next, we'll discuss some problems from Pathfinder where the piston will be having a mass, will have a friction. Then we'll discuss some problems in tomorrow's class. Let me not mess up things in first day, everything. Now let's do one thing. So pressure at 1 should be equal to pressure at 2. So what is the pressure at 1? F by A1. Pressure at 2 is, shall we write mg by A2? Is it pressure at 1 equal pressure at 2? No, they are not at same level, no? And what is the state of liquid? So here it will be like this, the transmission. Okay, of course, the pressure will get transmitted, but look at the level of liquid. The level of liquid is different here. So therefore, that H has to be blotted. So don't write directly P1 equal to P2, will go wrong. I think you look at the situation available. So write manometric equation. Write manometric equation. P1 or select a P2 plus rho GH minus P1 equals 0. What is the pressure at 2? Pressure at 2 is mg by A2. Rho GH F by A1. I think the end idea is the writing manometric equation. F is equal to rho G H1A plus mg A1 by A2. So what is the, you are supposed to rise it to height h and it should balance here. Okay, agreed, no? So this one, so is it pressure getting transmitted? Yes, it is getting transmitted. Again, don't think in other way that one. So what at this particular point the pressure should do, it should balance the weight and also the weight of this much of liquid column. Getting the idea? So the weight and this much of liquid column has to be balanced. For that you are applying the pressure. So if you want, you have to show arrow till here like this. So writing P1 equal to P2, you have to be a little bit careful. Okay, this is about the basic Pascal's law. I think it's what all we discuss, everything will be and enclosed, no? So this is enclosed here. Enclosed liquid. Within this, it'll get transmitted. So will it get also, will it exert force?